A parametric equation is when x and y are both given as functions of a third variable t, where x is equal to f of t and y is equal to g of t, where each value t determines a point xy which we can plot in the coordinate plane. It is important to note that in many applications of parametric curves, t does denote time, and therefore we can interpret xy to be equal to f of t, g of t, as the position of a particle at time t. It is important to recall the unit circle while doing parametric equations, especially the points 1, 0, 0, 1, -1, 0, and 0, -1. In example 2, we are asked to find parametric equations for the circle with center hk and a radius r. As a general equation, x is equal to h plus r times the cosine of t, and y is equal to k plus r times the sine of t. When you graph the circle, it is generally as shown below. On page 76, problem number 17 asks us to describe the motion of a particle with position xy as t varies in the given interval. Given the equation x equals 3 plus 2 cosine of t and y equals 1 plus 2 sine of t, we are instructed to describe the motion within the boundaries pi over 2 to 3 pi over 2. Your value for h is going to be 3, and your value for k is 1, based off of our previous general equations for x and y. Your radius is the coefficient in front of your trigonometric functions, which would be 2. So your center, hk, would be 3, 1, and your radius is 2. As a part of the problem, we construct a table where we plug in the values of pi over 2, pi, and 3 pi over 2 into our initial equations, which is when we recall the unit circle. When you plug in pi over 2 to the x equation, you get 3, and when plugged into y, you also get 3. For pi, you get 1 when plugged into x, and 1 when plugged into y. Similarly, when you plug in 3 pi over 2, you get 3 in x and -1 in y. Then plot the points on your graph and connect the points counterclockwise to create the parametric circle. Starting at the point 3, 3, our parametric circle moves counterclockwise to the point 3, -1, and this shows us 1/2 of a circle.